So here is the derivation for the variation of enthalpy with temperature and pressure. So essentially what we want to do is we want to come up with a formula where H is dependent on the variables T and P. So what we can derive from that is that the infinitesimal change of enthalpy is equal to the partial derivative of H with respect to P, at constant T, dP, plus partial derivative of H with respect to T at constant P, dt. So what we want to do next is we want to somehow simplify this or substitute in expressions that could make this expression a little bit easier to comprehend, I suppose. So we know that the partial derivative of H over T, this one, at constant pressure is equal to the heat capacity at constant pressure. So we can go ahead and substitute that. So we still keep this. Now we have our heat capacity at constant pressure times dt. The problem is that there's nothing that this really connects with. So our goal is to define this term in variables that are recognizable. So to do that, we're going to impose the constraint that enthalpy is constant. So that means dH is equal to 0, and this evaluates to 0. So we want to solve for just this part of the equation. So in order to do that, we're going to move this term to the other side, and then divide by dP. So dividing by dP gets rid of dP on the left side, and then dividing by dP on the right results in the following. Partial T with respect to P at constant H. So this term is a recognizable quantity, and this is called the Joule-Thomson coefficient, which is noted by a mu. So the partial derivative of T with respect to P at constant enthalpy is the Joule-Thomson coefficient, and we can now define partial H with respect to P at constant T to be equal to negative mu Cp. Great, so now we have Cp equaling partial H with respect to T at constant P, and now we have negative mu Cp being equal to partial H with respect to P at constant T. So now we can rewrite our dH expression. dH is equal to negative mu Cp dP. Notice that these don't go away. Plus Cp dt. And this expression basically shows the dependence of enthalpy on the variables of pressure and temperature.